All right, so today we played around with Chromebooks and we talked about translations of graphs and we looked at some different things of what different values would do to our graphs. We are starting Unit 3, Module 5.1, Translation of Function Graphs. It is important to know that g of x and f of x are both functions. F of x will always be the parent function, what it looks like without making any changes to our graph, and g of x is always going to be the new one. So it'll always be after we make some type of changes. So our generic function, g of x equals a times f. F is our old function, what we call the parent function. 1 over b times x minus h plus k. Now it looks like a lot, but I promise you, very rarely will you have all of those changes happening. A lot of times will be one or the other. A stretches the graph vertically. B value stretches the graph horizontally. B can be a little tricky because notice it's 1 over b. So when b is a fraction and it's written as 1 over b, it stretches. But when it's a whole number, because it's 1 over, it means it's been flipped and it actually compresses our graph. H translates the graph horizontally, which means it moves it left and right. Notice it's minus h. So when h is and it says minus, it's actually going to move it to the right. When h is a positive, it's going to move it to the left. So it's almost the opposite. And k translates the graph vertically. So it just moves it up and down. A, B, h, and k are changing the way the graph f of x, the parent function, looks, creating the new graph g of x. B and h change the x value. A and k change your y values. So we're going to practice writing g of x in terms of f of x after performing the given transformations. Now, when you look at these pictures, we're going to write the equations. We're going to look at the blue graph, and we're going to decide what is happening to the blue graph to make it go to the pink graph. Okay? So, looking at this first one, we need to identify which way did it move. Did it stretch it? Did it compress it? Did it move it up? Did it move it down? Did it move it left? Did it move it right? So if we look at the blue to the pink, we actually moved over 3 units. And I can look at that because this endpoint here matches with this one. So we went over 1, 2, 3 units. We went left 3 units. Moving left is a horizontal movement. That means we changed h. We didn't move the graph up or down. We didn't stretch it. We didn't compress it. This equation is very simply, remember, we're going to write it in this format. So we simply say g of f equals, or g of x, sorry, equals. Now, moving a left is horizontal. It is our h value. H is that horizontal translation. So we simply look at this equation. We don't put anything for a, b, or k. And we simply say that's f x minus 3, because we moved 3 to the left. Now, moving 3 to the left means it's minus, let me see if I can move this 2 over. It's a minus a negative 3. So what happens when we have that double negative? Well, we clean it up and it becomes a positive. So that's simply g of f equals f of x plus 3. That tells me I took my parent function, my blue one, and I moved it over 3 units to the left. Now, let's look at number 2. We're going to do the same idea. We've got to first identify what's happening between the blue and the pink. It didn't move it left or right. It didn't move it up or down, but it stretched it left and right. Left and right is always a horizontal, and it's a horizontal stretch. It actually went out how many times? So what would I multiply the 2 by to make it 6? We'd multiply it by 3. So looking at that, it's a factor of 3. Remember, stretching horizontally, stretching it out, is our b value. We don't put anything for a, h, or k because we're not messing with those. So we get g of x, let me use the black one, g of x equals, and remember, we're only dealing with the b, f of 1 over. Now, how many times did the blue become pink? It was 3. It's always written as 1 over, so we put the 3 in for the b. And it's just simply an x. because we're not adding in h or k. All right, so one more that we're going to look at, the difference between the blue and the pink. This one's a little different because it flipped it over. It's actually flipped over the x-axis. But you need to think about, if we flip over the x-axis, what values are changed? Well, the y value went from a positive 3 to a negative 3. And that means that it's that vertical. So it's changing the y values. The x values are actually staying the same. The y values are what changes. And since it flipped it over, it didn't change anything else. Everything else lines up. It's a mirror image. It's a reflection. So whenever it's a reflection over the x, that means we're changing our a value. It went from positive 3 to negative 3. So we're not changing the number, just the sign. So that means that a is a negative 1. And you can write negative 1 or simply write negative f of x. And that's taking the equation. We didn't make any other changes to it. So now we're going to look at some quadratics. And we will practice more of these in class tomorrow. Make sure you write down the notes. Make sure you get these examples into your notes. And remember, we're going to use Cornell note style, so we should be making sure we leave that space so we can write our questions in. So quadratics, you need to remember that a quadratic is a parabola. It's a U-shaped. So it either opens up or down. And given the equation, we're going to describe the transformation of f of x to the graph, and then we're going to, and I should say then, we're going to graph the g of x function. So we're gotten this equation. What we need to identify first is a, b, h, and k. And remember, sometimes it'll have values and sometimes it won't have values. And that's okay. We're going to look at what it's doing and identify what those changes do. So let's identify. A is negative 3. B is just 1. There's no b value. H is a positive 2, because remember it's minus h. And k is negative 4. Now, we're actually going to write in, what do those values do to our graph? Well, the negative on the a reflects it over the x-axis. So we're going to write in that it reflects over the x-axis and then what it stretches. So we reflect over x-axis. Okay? It also stretches the graph by a factor of 3. So we stretch. And remember, A stretches vertically. So we stretch vertically by a factor of 3. And you want to make sure you're using your academic vocabulary. Reflect, stretch, vertical, factor. Okay, those are key things. B is 1. That means B doesn't do any changes. Anytime the values A, B, H, or K, well, I take that back. Anytime the values of A or B are 1, we're not making any changes. So this has no change. But H being 2, that means we're going to translate, because if you look back at your equations of H, you can identify that H does the translation horizontally. So this is moving horizontally. It's a positive, so it's going to go horizontally to the right. So this translates horizontally 2 units right. And then K. K is a negative 4. K does the translates vertically. So we're going to say if this translates vertically 4 units down, because it is negative. So this is the first part. This is given the equation. This is describing our transformations. Now we're actually going to graph the equation. So there's a couple ways of doing this. when we're dealing with quadratics and when we deal with any of the other functions that we have, we're always going to have what's called reference points. Those are very easy points to work with that are on the parent function. And for a quadratic, our reference points are 1, 1, 0, 0, negative 1, 1. And if you look, they're the 3 points that are on the graph. We use them as reference points because they're easy to deal with because you're adding and subtracting values to 1 or to 0 and multiplying. So it makes their numbers very simple to deal with. So the way I like to do these, and I am a little unique with this, the book I believe shows you a little bit of a different way, is I like to look at what's happening. So when we factor means to multiply, and this is changing the y value because it's a reflect over the x, it changes your y. So that means on each of our points, I am going to multiply the y value by negative 3. So I like to write that there. B doesn't do any changes, so we don't mess with it. H translates horizontally. Horizontal is your x value, so we're going to add 2 to the x values. So for each x value, I'm going to plus 2. So I'm just kind of writing it in above here, what I'm going to be doing. K says translates vertically down 4. That means it's adding or subtracting. Since we're going down, it subtracts. So after I multiply it by negative 3, I'm going to subtract 4. So what I'm doing is I am taking the values, and I'm going to write this out a little bit bigger so you can see. And I'm going to take this value, I'm going to add 2 to it. The y value, I'm going to multiply by negative 3 and then subtract 4. And we're going to get new points. So this one, 1 plus 2 is 3. 1 times negative 3 is negative 3 minus 4 makes it negative 7. There is a new point on our graph. 0 plus 2 is 2. 0 times negative 3 is just 0. And then minus 4 makes it negative 4. And then for the last one, negative 1 plus 2 is 1. 1 times negative 3, 1 times negative 3, is negative 3, minus 4 is negative 7. So now, we're going to graph those new points. And I know it seems like it might be a little bit more work to do it this way, but trust me, as we go through these units and you do this with each of the functions, you'll start doing mental math and it will help. So, we're at 3, negative 7, and it doesn't look like my graph goes big enough, but we're going to imagine it's down there. Okay? And then we're at 2, we're at negative 4, so we're going to go right here. And then at 1, we're at negative 7 in here. So our graph, and I've ran out of room, is down there at the bottom looking like that. So it's an upside down face. It has been reflected over the axis, it's been shifted over to the right, and it has been moved downward. So we're going to look at another one. Try it again. Remember, all parabolas, the basic function of a parabola is f of x equals x squared. And that's what I've graphed in blue again. This time, our equation is g of x equals f of 1 over 2, x plus 5 plus 2. So we're looking at what this graph is doing. We need to identify a, b, h, and k. Since there is no value out here, our a value is simply 1. Our b value, remember it's written as 1 over b, so b in this case is 2. H. Now, you got to think back and look back to your equation. H is supposed to be a minus the value. So that means that this had to be a negative number when I put it in, so it's negative 5. Whoops, that did not write. And then 2, that's our k value. So we're going to put that right here. Now we're actually going to write out. Since a is 1, it makes no change. B is 2. Remember, B is changing it horizontally. So this is stretching the graph. Graph horizontally. by a factor of 2. Since h is -5, h does that translation horizontally. So that means that we're moving. We're translating horizontally left 5 units. Remember, translating is just sliding it over. K is 2, which means we are translating vertically. So we are translating vertically. It's positive, so we're going up 2 units. All right, so again, this is our parent function, same reference points, but we're going to change them differently. So we're looking at this. Remember, our b value stretches the graph horizontally. That means we're multiplying the x value by 2 on each of these 3 points. H is to translate horizontally. It's still messing with your x value, and it's left 5 units. So after we multiply by 2, we're going to subtract 5 to the x value. And then k, we're going to go up 2 units. So we're going to add 2 to our y value. Now, please don't multiply or do the 2 minus 5 and go -3. It doesn't work that way. I mean, the answer in this case does come up -3, but it doesn't work that way because this one's not -3. So when I multiply by 2, 1 times 2 is 2, minus 5 is -3. 1 plus 2 is 3. Here, 0 times 2 is 0, minus 5 is -5. 0 plus 2 is 2. Here, -1 times 2 is -2, minus 5 is -7. And 1, and this should be 1 plus 2 is 3. Now, we're just going to graph those new points. And we've done what the directions have said. So we're at -3, +3 right here. We have a point at -5, +2 right here. And we have a point at -7, +3 right here. Whoops, I missed that mark. And so here is our new parabola. So we've taken it and we've stretched it out so it looks a little wider and not very symmetrical here. Here, maybe if we made it look like that. Looks a little more symmetrical. So we've stretched it out, we've made it look wider, we've moved it to the left, and we've moved it up. And that's exactly what those values in the graph are telling us it was going to do. Now, we have one more that we're going to look at. It's a word problem, and I know you guys all love word problems, but I promise it's pretty painless. There are key points here. Let's move our swivel over just a little so it makes a little more sense. We have an old stone bridge over a river. Uses a uses a parabolic arch for support. In the illustration shown, the unit of measure for both axes is feet. The vertex of the arch is at point C. Find the quadratic function that models the arch and state the function's domain, x values. So we need to identify some key info. The shape, the vertex, and the other 2 points. We're going to actually go through and write the equation here. So the shape, they already told us. The shape is a parabola. The vertex, they told us, was point C, and they actually gave us the values. So all we have to do is look at the graph and grab those values. So let's go ahead and write in our shape that of a parabola. The vertex is 27, -5. The other 2 points, 2, -20. And what, 52, -20. So we need to figure out what the equation is. So we need to say, all right, we've got g of x equals a times f of 1 over b x minus h plus k. Now, some of these we may fill in and have values for, some may not have values for them. In this case, it doesn't look like we're going to have a b value, but that's okay. We're not going to stretch it out. We'll be looking for, they gave us the equation. Let me fix this. They told us the equation would actually be written in this format. So they're telling us the equation does not have a b value, that we do have an a value. Very rarely do you have a and b. All right, so the first thing is to identify your vertex. This vertex is important because this is actually your h and k value. So guess what? We're almost done writing the equation. So we have g of x equals a times f x minus h, which is 27, plus k, which is a negative 5. So we write it as a minus 5. So all we have to do is figure out a. To find a, we're just going to simply pick a point that we were given and plug it in. You can use 52, negative 20, or you can use 2, negative 20. I would prefer to use 2, negative 20 because the values are smaller, okay? Putting in smaller values makes life so much easier. So when we plug in values, quite honestly, it doesn't matter which ones you plug in. You're still going to get the correct answers. So we plug in 2, we get 2 equals a times, we have f, we're going to plug in the, this should be negative 20 goes here, and the 2 goes in for the x, because this is x, this is your y value. 2 minus 27 minus 5, okay? So all I've done is plugged this value, x, y, but y is really that g of x value. And we're going to simplify. So I get negative 20 equals a times f of, what's 2 minus 27 is negative 25 minus 5. Now, this right here, this is kind of the tricky part. This says I got to evaluate the function f of x at negative 25. Remember, f of x is x squared. So if I plug in negative 25 here and I square that, I get 625. So my equation now becomes negative 20 equals a times, not f of x, 625 minus 5. Add your 5 to both sides. It's negative 15 equals a times 625. Divide out the 625. Yeah, I know, it seems like a lot of work for just a simple little problem. When you reduce that down, you can divide top and bottom by 5. You get negative, let's see, because I've already done the math, 3 over 125 is a. So we go back to our equation and we say, all right, here, g of x equals negative 3 over 125 times f of x minus 27 minus 5. And we're done. There is our function. There is our equation. And it asks us to state the domain. The domain is simply your x values. Well, our bridge goes from positive 2 to 52. So we say our domain x such that 2 is less than or equal to x, which is less than or equal to, whoops, not 25, but 52. And there we have it. So make sure you get good notes. I will see you in class tomorrow.